Good morning to Professor. This is my project proposal. My title is Electricity Supply and Demand Forecasting using Support Vector Machine Regression Model. Okay, for introduction. Research background. Electricity plays a basic part of nature, which is one of the most widely used forms of energy during daily life. The supply and demand issue is very important to be considered as the development of new technologies such as artificial intelligence, automated machines, robotics, electric vehicles, and so on. It can be generated from coal, gas, oil, hydroelectric, nuclear, wind, solar power, and biomass. So according to a data set by Kementerian Tenaga dan Sumber Asli, KETSA, Malaysia, so we can view that the electricity supply and demand is keeping increasing, which showing a positive trend from 1978 to 2016. So modeling electricity supply and demand by using regression model is widely applied in research area before, which one of the common and useful model is the SVR model, which is support vector machine regression model. So it proposed to find a hyperlength in an n-dimensional space, which can classify the data points. Electricity supply and demand are divided into different sources and type respectively. So demand of the electricity for commercial just follow behind the demand of electricity for industrial, which implies it plays a very important role in the daily life. To overcome the infection of increasing consumers of electricity, predicting supply and demand of electricity is necessary. So the problem statement. First, the multi-source of supply of electricity. So from the data set we obtained, for the data set I obtained, the supply of electricity can be divided to hydroelectric power, thermal station, cogeneration power, importation from other countries, where the type of demand of electricity can be divided to on use by station itself, residential, commercial, industrial, transport, and agriculture. So the next problem statement is the suitability of support vector machine regression model to solve this problem. So SVR model is often used to model data for forecasting, which is able to solve big data classification problem and help multi-domain application in a big data environment. Okay, research objective. So the first objective is to model the historical data of the supply and demand electricity based on different categories and the Malaysian population by year. Next, to forecast the electricity supply and demand in the next 10 years. So third, to determine the suitability of solution based on the error analysis on mean absolute percentage error, MAP, and root mean square error, RMSE. So the scope of study. This study is focused on forecasting the electricity supply and demand in Malaysia. The historical data are retrieved from KETSA, sorry typo here, and Department of Statistics Malaysia. SVR model method is used in this study. Software used are MATLAB, RStudio, Waikato Environment for Knowledge Analysis, which is known as WITA, a data mining tool. This study is significant, which contribute the knowledge of the forecast methods on electricity supply and demand in Malaysia, and contribute information to the government sector and be an effective reference to strategy for electricity supply. So literature review. First, SVR model. It is a suitable algorithm to solve multidimensional function in which is forecasting problem by Nick 1996. It extends a function with high dimension by a small basis from the model. So this model was used before to forecast the regional electricity load in Taiwan from Tai and Hong in 2005. So SVR model does not based on the principle empirical risk minimization, where it is based on structural risk minimization. It can solve forecasting problem by nonlinear regression, which, for example, financial forecasting using time series, prediction of air quality, and so on. So long-term electricity demand forecasting is essential to analyze and play the electricity supply by Kate 2020. We must identify the strongest effects indicators which relate to the electricity supply and demand of a country to compute an accurate model. So the next is electricity supply and demand. Electricity supply is rising in developing countries from 2020. So it plays an important role to affect the economic growth and social welfare. Hence, it must be affordable, accessible, and lead to a smaller bad impact to the environment. This is by Rivera and so on, 2019. So institutions and organizations from numerous countries has conducted a lot of research to model the consumption of electricity, which will directly relate to the management of electricity supply. The integration of new technologies as electricity consumers, such as electric vehicle and energy storage, I said before this, cause the uncertainties in terms of the new future electricity demand and continue to the future electricity supply. This is by Mer and so on, 2020. So the rise in global electricity demand is expected to grow more than twice the rate of global energy demand. Okay. Why Plato Environment for Knowledge Analysis, WITA? WITA is a data mining tool. Data mining is a process of classification of cases based on data characteristics collected from a dataset automatically. It is used to extract information which will be useful for decision support. So WITA was designed by using Java programming and proposed to be machine learning algorithm which is able to do data preparation, classification, clustering, association group, mining, visualization, and regression. So in this study, SMO regression program in WITA will be used to generate the support vector machine regression model, which forecasting the electricity supply and demand. So methodology. So this is the support vector machine regression model. So according to Cha, Hua Ho, and Chin Lin in 2012, linear support vector machine regression model can have a good MSE values as nonlinear SVR if the dataset has many features. The formula used in SVR are shown as here. So this is linear support vector machine regression model, and this is for nonlinear. And K represent the kernel function. Okay, so what WITA? So this is some of the interface of WITA, which shows the output of forecasting result, and also the graph plotted, and also the error analysis of forecast data. So this is the operational framework. First, we collect data, then we format data suit in WITA, which is in ARFF form. So we use the SMO regression in WITA to program generate a prediction model, and the WITA will train and test the model using program automatically. Then we test the result which is optimized or not. If no, then we find a new suitable criterion for the program to generate a new model. If yes, then we collect and evaluate the forecasting data, and we do the analysis of the model error and the data. So the subject and data source. The data source for electricity supply and demand is taken from energy supply and demand for electricity dataset by Mampu from CASA. So data retrieved are from 1978 to 2016. So the Malaysian population is provided by Department of Statistics Malaysia. So the data analysis, the error analysis are based on MAPE and RMSE. So this here is the formula for root mean square error and means absolute percentage error. So the assumption and limitation. So first we assume that all data collected is valid and accurate. Next, the data set follows a regression trend, which affected by numerous of supplying source and demanding types of electricity energy. So the result generated by SMO regression in WICA can represent the algorithm of SVR model, which is the main regression model used in the study. So this is the Gantt chart for this study. Okay, expected finding. So we use the data retrieved from the sources, and we try to forecast the result from 2017 to 2022. And here is the predicted supply and demand in unit kiloton. Okay, so this is the graph plotted by type of demand against the year. The purple represents the total demand, and each one represents the type of demand of electricity. So from here we can notice that as the time goes, the demand for industrial is much higher than others. So the next one, the graph is trend of supply for electricity against year. So similarly, we can know that the supply by thermal station is the highest for the electricity energy. So graph total supply and total demand and population against year. So we see when the time increase, the population, total demand, and total supply is keep on increasing. So and among them, it show a positive relationship, which the higher the year, the higher the tree of the data. So from the result generated by SMO regression in WICA, we can obtain the weights of each independent variable in the equation, which shown as below. So the weight for each normalized import, export energy, supply by hydro, supply by thermal, blah, 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 and Malaysian population is also total supply is, and also the y-intercept. So here is the equation. So the area analysis can be done by using the outcome result by WICA and the data provided by CASTA and Department of Statistics Malaysia from 2017 to 2022, so that we can test the accuracy of the result. So in conclusion, support vector machine regression model can be used for forecasting electricity supply and demand. Waikato Environment for Knowledge Analysis, WECA, is the data mining tool which able to generate the SVR model by using its SMO regression function. Error analysis can be done based on root mean square error and mean absolute percentage error, which can determine the accuracy of WICA's outcome with the real values by CASA and Department of Statistics Malaysia. Thank you.